All right, so I had a question about number 7. Number 7 is the Q. You know, just calculate Q. And so, what was it? 2NO goes to N 2O2? Is that it? Yeah? No? NO2s. Alright. N2O4 gas goes to 2 NO2s. That's it? Gas? What I'm saying is that the initial condition is 1.0 molar, 1.0 molar. No? What was it?
Is that that one that's like 10 to the negative 5th power or whatever? It's right. What number was that?
Yeah.
This one goes straight from 2 to 9.
Well, basically it's a Q problem, and so what you're going to do is you're just going to set it up Q, products over reactants.
Check the value versus the KC value, right?
Right, and then just compare it to K. Oh, I didn't put K.
Yeah.
Okay, then it's impossible to solve. Yeah. All right, so that's probably your question then, huh? All right. Kelly?
Okay, when do you use QC and when do you use KC?
When you use Q, Q is just for predicting shifts. If it shifts left, shifts right, or doesn't shift at all, you use Q. Use K for everything else.
I know, but we always have the initial concentration.
No, sometimes I give you the equilibrium concentration.
Yeah, he's done that before. Use that value.
Yeah, so you don't always do a Q. In fact, I never do Q unless I need to know what direction it shifts and I can't tell. What's faster than doing a Q calculation is just to reset it if I don't know which way it's going to go. If I reset it, then I know which way it's going to go. Okay. Uh-huh.
Which one was it when it shifts left? Q is greater than...
When Q is greater than K, it shifts left. Yeah, you're right. Shifts left. Kelly, you had a question too?
Yeah, I got another question.
All right, go ahead.
When do you reset and when do you not reset?
Okay, the simple answer to that is if you don't know when to reset and when not to reset, then don't reset. You don't have to reset. Don't reset. You know the reason I call them tricks? I don't call them, I don't call it step 1, step 2, step 3. I call them tricks is because what happens is, the math gets too difficult, and then you start looking for tricks to make the math easier. That's all. And so that's when you start thinking about resetting. But after you've done enough of these, then you'll see automatically, oh, this is going to be problematic. I'm going to just go ahead and reset it because I can already foresee it's going to be a difficult problem, right? So that's why, I gave you a general strategy of resetting, But you don't need to reset until the math gets too hard. Okay? Then reset or try everything. Just don't leave the page blank.
Okay.
That calculator is officially not allowed. You're supposed to use the non-programmable. But like I said before...
Sandra, you heard what he said on the first day?
Well,
Yeah.
you need to borrow a calculator? I don't have one, unfortunately. Maybe you have a friend who has a backup calculator. Or just save all the calculations with
I got a backup calculator.
most people, that have those programmables carry a backup calculator too.
Or if you buy them at the 99-cent store, it's better to have two.
Those ones don't.
They work, man.
Okay.
That's $1. I can't beat that.
Oh, you can't beat that. We used to have 16 of those, and now they're all gone.
They last about a year, so.
Yeah. Yeah. All right. Any other questions?
I have two. I can let him borrow this, but then I have to use them.
Oh, that's a good one.
Okay. We'll see if Will finds a calculator or not, but that's it.
Yeah, we're good.
You're good. All right. Well, Kelly, you know what I said about resetting is, you know, if K is big, you then reset it to the right. If K is small, reset it to the left. You know, unless it already is. That's all.
I want to clarify something. Is the rule of 100 hard simplifying assumptions?
You mean the ratio for the simplifying assumption?
No, the rule of 100.
The rule of 100 for the simplifying assumption, I don't bother with. I don't, unless it's very big. If it's very big, then you know it, you know? Okay, basically what she's asking is, for the simplifying assumption to work well, you want a big initial and a small k, right? Big initial and a small k, we take the ratio of that and see. If you take k, the initial concentration over k, and it comes over 1,000, then likely the simplifying assumption is going to work. Yeah.
That one's talking about that this morning. So it's merely called simplifying assumptions.
Huh?
So the rule of 100 is merely called simplifying assumptions.
The rule of 100, I don't know. We're talking about a different rule then. I've never. Tell me.
This one video this morning, and I was confused.
Oh, good.
Wait, how do you use the 5% rule? Like the percent change.
If the percent change is greater than 5%, the simplifying assumption fails.
No,
Yeah.
but how do you calculate the percent change?
You just do the change over the initial.
So,
So equilibrium divided by the initial.
This is the initial, this is the change. So it's 3x over 1 times 100. Whatever this initial is, it could be 0.100 minus 3x. 3x is the change, you know?
Uh-huh.
It's just whatever you're losing. Or, yeah, that's it. All right, well, what we're going to do today, we're going to do the lab, and then we'll take the test. So why don't you just continue working on the lab? Excuse me, and then we'll take a break and then have the exam.